Hello and Assalamualaikum to all. Today we are going to study 3.2 Empirical and Molecular Formula. So what is empirical formula? What is empirical formula? So empirical formula is the chemical formula that show the simplest ratio of atom present in a compound. And molecular formula shows the actual number of atom in a molecule. Okay, let's see example. If the molecular formula of a compound is C4H8, we can simplify this to become empirical formula, that is CH2. Means that this one is divided by 4, right? C4H8 divided by 4, so you get CH2. So the relationship between the molecular formula and empirical formula, we can see from this formula. So molecular formula, we can relate with empirical formula by looking at N times empirical formula. For example, the molecular formula that we get here, this one, C4H8, is actually N, which is 4 here, multiplied by CH4. 4 times C, 4 times 1, okay, C is 1 here, so it becomes 4. 4 times 2, H, so it will get 8. So C4H8. But what is N? So N is where the molar mass of the molecule divided by mass of empirical formula. Okay, let's see example. So example, CH2. Okay, CH2. The mass of CH2 is actually 12. Carbon is 12. Carbon is 12 times 2. Okay, because hydrogen is 2. And 1 here refers to mass of hydrogen. So you add up all this number, you get 14. Okay, 14 is the mass of CH2. CH2 is the empirical formula. So 14 is here. Mass of empirical formula. And for the actual formula, molecular formula, so C4H8. So 4 times 12. 12 is the carbon. And 4 here refers to there are 4 carbon in the molecular formula. And 8. Okay, 8. Okay. And 1. 1 is hydrogen. So 1 is hydrogen. So add up all the number here. So you will get 56. Okay, so 56. So N, what you get is, okay, this is 56. Okay, 56. So molar mass of the molecule divide by mass of empirical formula, you will get the number 4. So that is the relationship between molecular mass and empirical formula. And also, what is N? How can N comes in this equation? So how to determine empirical formula? There are 3 methods. You can use mass of compound, if it is given mass of compound. You can also calculate if percentage is given. There is no mass, but what is given for you is percentage only. Or using combustion data. When something is burned, a sample is burned. Okay, but that sample must be either hydrocarbon or organic compound only. CHO or CH only. Carbon and hydrogen, or carbon, hydrogen and oxygen. Okay, so let's see the first one. How can we determine the empirical formula? By using the mass of the compound. So let's see. A sample of compound contain 4 gram of calcium and 7.1 gram of chlorine. Calculate its empirical formula. The question asks you about empirical formula. So AR here refers to a relative atomic mass. But relative atomic mass is the same number as the atomic mass of the element here. So let's try to calculate this one. So calcium. You need to draw a table first. So this table. 3 row element which is calcium, chlorine, and then all this must be written in sequence. So mass, number of mole, simplest ratio, and also empirical formula. So calcium, what is given for you is 4 grams. So just write down 4.0. And chlorine 7.1. So this is the mass that is given. Okay, the mass that is given. So number of mole, you need to remember the formula of mole. Okay, mole is equal to mass of the element or the compound over molar mass. So in this case, the mass is 4.0 divided by molar mass of the calcium. So calcium given for you there 40.1. 40.1. So it is actually 0.09975, which is almost equal to 0.1. We can round it off because this number is very close to 0.1. And the same thing for this one. Calculate the formula. Calculate using the formula of mole. Mole equal to mass over mr. So mass here is given 7.1. So 7.1 divide 7.1 divide by 35.5. 35.5. So your answer here should be 0.2. 0.2. And simplest ratio. Okay, how to calculate simplest ratio? You compare the smallest number between the mole that you have calculated here. 0.2 and 0.1. 0.1 and 0.2. Which one is smaller? Of course, 0.1, right? So what you need to do is you write down 0.1 divide by the smallest number 0.1, which is equals to 1. And this one 0.2 divide by the smallest number that you have chosen earlier. So this one is 2. And because of this, CA, and what you get is for CA is CA2, and this one, sorry, CA1, and this one is 2, so CL2. So empirical formula is actually CaCl2. Okay, so that is how you are going to find out the empirical formula using masses of compound. Okay, are you still with me? I hope you are. Don't skip this video. Okay, next, number 2. By using percentage of composition. Okay, percentage. From the word here, what we are looking for is percentage. Percentage. So mass is not given, but percentage. So given for you a sample of hydrocarbon. So hydrocarbon, this is very important word. Hydrocarbon means that it only contain carbon and hydrogen only. Hydrocarbon. If it's say organic compound contain carbon, hydrogen, oxygen. So a sample of hydrocarbon contain 85% of carbon and 14.3 hydrogen by mass. Molar mass is given. Molar mass is given. This is not the mass of the hydrocarbon. This is the molar mass. Molar mass means that if you have 1 mole, that is the mass. But we don't know this hydrocarbon. Is it 1 mole? Is it 2 mole, 3 mole, 0.5 mole? We don't know. And the question also asks you empirical formula and molecular formula. So let's see how to solve this one. So what you need to do first is to assume the mass that is 100 gram. You need to assume it is 100 gram. When you assume it is 100 gram, means that 100 gram is equal to 100%. Okay, let's see. You still need to do this table: element, carbon, hydrogen, mass, number of moles, simplest ratio, and empirical formula. All this must be in this form. So carbon, what is the mass? We don't know. But what we know is if 100 gram equals to 100%, 85.7%, is it logically 85.7 gram? Logic, right? Because 100 gram, 100%. 85.7% must be 85.7 gram. And the same thing for this one. 14.3% is also equal to 14.3 gram. Because you assume 100 gram is equal to 100%. Okay, so we get the idea now. Okay, so number of mole. Okay, mole, again, the formula is the same. Mole equal to mass over mr. So the mass, take this one. For carbon, take this one. 85.7 gram over mr. mr for carbon. 12, right? So you need to calculate this one. So I already calculate. So 7.14. And this one, the same formula, mass over mr. So mass is 14.3, this number, over Hydrogen is 1. So you get 14.3. So simplest ratio, okay, simplest ratio, look again at this number. Look again at this number. Which one is smaller? Which one is smaller? So this one, right? So this one. This one is smaller. So this one is smaller number. So for the smaller number, you calculate 7.14 divide by itself, because this is the smaller number that you choose, equals to 1. And 14.3 divided by 7.14 is actually almost equal to 2. Okay, the sign that I show here is almost equal. Maybe it is 2.009 or 1.99 something, but actually it is nearing 2. Okay, so this one will become C1, C, and this one is H2. So the empirical formula is actually CH2. So that is the empirical formula. Always write down this thing, your final answer. Better if you write down empirical formula is CH2. Okay, so you get the answer, CH2. Okay, we already determined the empirical formula, but this is not the end of the question because it asks you about molecular formula. So how can we find out molecular formula? So for you to calculate the molecular formula, you need to find the N. Okay, so how to find the N? So again, the formula for N that you are looking for is molar mass of the molecule divided by mass of the empirical formula. Okay, molar mass of the molecule. Molar mass of the molecule here already given. So let's see. This one, this part. Okay, this part. Okay, let me change the pen. How to change the pen? Okay, pointer option, highlighter. Okay, I want to highlight this one. Okay, so this is the molar mass. Okay, molar mass. Okay, change the pen. Okay, so N equals to 56. We already get the number 56 divided by mass of the empirical formula, CH2, right? So CH2 is, carbon is 12 plus 2 times 1. Okay, so this one equal to 56 over 14. So 56 over 14 is 4. Okay, so we get the number 4. And for you to put the number 4 in your equation, it will be like this. Okay, molecular formula. This is what we are looking for. So what is the molecular formula? Okay, we know the molecular formula and we know the N. So N equal times CH2. So this is the empirical formula, right? So N we already know, which is 4 times CH2. So 4 times carbon is 1. So C4, 4 times 2 hydrogen here. So it is 8. So this is the molecular formula that you are looking for. Okay, so that is how you are going to find using percentage. And also how to relate to N to find the actual molecular formula from the empirical formula. Maybe you need to repeat this video a few times for you to get more understanding from it. Okay, this is the proper one. Okay, let's see the proper one. The same thing. Okay, C4H8. Okay, combustion data. Okay, what if we are going to calculate using combustion data? 1 gram of sample of organic compound. Okay, organic compound. Organic compound means that this one contain carbon, hydrogen, oxygen. Carbon, hydrogen, and oxygen. If it is not written organic compound, it is written hydrocarbon. It is only carbon and hydrogen. Okay, the compound is Z. Z was burned in excess of oxygen. The combustion produced 252 gram of CO2 and 0.443 of H2O. So the question only asks you about empirical formula. So step 1, what you need to do is to calculate the mass of carbon, the mass of hydrogen, and the mass of oxygen. Okay, it's like this. If you were to imagine, we have a sample. So let's say this is a sample. This sample is burned. This sample is burned with fire. Okay, this is fire. This sample is 1 gram, and inside this sample, it contains carbon, hydrogen, and oxygen. Okay, after you burn this thing, you get, okay, the gas CO2 2.52 gram plus H2O. This is H2O. Okay, let's just write down like that. H2O. So H2O is 0.443 gram, and also you get oxygen. And oxygen here, we don't know what is the mass that is produced. So you need to find out how many carbon in CO2, how many hydrogen in H2O. Okay, let's see in mathematic form. Okay, we know the mass of carbon dioxide, 2.52 gram. Okay, given here. This is this part. Okay, given for you. Okay, so we need to find out the mass of carbon in CO2. We want to find carbon in CO2. So how to calculate? Okay, so carbon in CO2, carbon is 12 gram. Okay, actually this thing is actually carbon over CO2. 44 is CO2, molar mass for CO2. 12 is carbon times 2.52 gram of CO2. Okay, I hope you are clear about that. Okay, so we get the amount of carbon in CO2 that has been produced in 2.52 gram is actually 0.6873 gram. That is mass for carbon. Do the same thing for hydrogen, but remember hydrogen is H2 here, H2O. So mass of hydrogen in H2O, okay, that's why it is 2 here. Okay, that's why it is 2, because hydrogen is H2O. Over 18. 18 is the mass of water. Okay, this is mass of water. So actually it is like this. 2H over H2O, 18, times 0.4483 gram. And you will get 0.0492 gram. Okay, remember again, we have the sample. The sample here is 1.0 gram, right? And inside here you have carbon, you have hydrogen, and you have oxygen, right? So you already know the amount of carbon that you calculate is 0.6873 gram, and hydrogen here is 0.0492 gram. So what is the mass for oxygen? You can calculate this one, right? So it means that 1 gram here, okay, 1 gram here, mass of sample, right? Okay, mass of sample is 1 gram. 1 gram equal to mass of carbon plus mass of hydrogen plus mass of oxygen, right? So 1 gram, you already know mass of sample is 1 gram. Mass of carbon, you also know it, 0.6873. Mass of hydrogen, we also know it at 0.0492 gram. So can we find out the mass of oxygen here? We can, right? We can. We add this number. And then 1 gram minus this number, right? Okay, the total minus this number, mass of carbon plus mass of hydrogen, you should get mass of oxygen, right? Okay, let's see a proper calculation. So mass of oxygen is mass of sample minus mass of carbon plus mass of hydrogen, just like what I've shown to you earlier. So 1 minus all this, so you get 0.2635. Okay, now if you add up all this number, mass of carbon, mass of hydrogen, mass of oxygen, all this must be equal to mass of sample. Okay, which is 1 gram. Okay, so you try to add up. You should be able to get 1 gram. because that is the mass of sample that contain carbon, hydrogen, and oxygen. Okay, so this is step 1. Okay, step 2. So this is step 2. Okay, why the value will differ? 73. This one is 73, sorry. 92. And this one's 2635, sorry. Okay. But it's okay. Only a little bit of difference. So number of mole, mass over mR. Okay, that is the mass 0873 over 12. So you will get 0.0573. This one 0.0492 divided by 1. So 0.0492. 492. And this one 0.2635 divided by 16. Okay, so this one you will get 0.01641. Okay, let me erase this one. 492. Okay. Okay, so simplest ratio, look at the number here. Which one is the smallest number? Okay, this one is the smallest number, right? Okay, this one is the smallest number, so we need to pick that one. So when you pick that one, it means that everything must be divided by the smallest number, 0.01641. This one must also be divided by the smallest number, 0.1641. And this one must also be divided by the smallest number. This one, 1641, means that this one will become 1, right? But what about this one? 0.0492. And you should be able to get 3.0. And this one 0.0573, you should be able to get 3.5. Okay, 3.5. So how can we get simplest ratio? This one is 3.5. It cannot be C 3.5, right? It cannot be C 3.5 like that. So what you need to do is to try to multiply this number with a number that can make it whole number. Okay, in this case, actually, you need to multiply by 2. When you multiply this one by 2, everything else must follow. Okay, so this one is actually 7. This one is 6 and this one is 2. So your empirical formula is actually C7H6O2. And that is your empirical formula. It's okay if the number looks like this, 762. Because when we calculate, based on the data that we get, that's the answer that we get. So that is correct. Okay, so be careful. Combustion of hydrocarbon, remember, hydrocarbon only involve carbon and hydrogen. X, Y here refers to the stoichiometry, the number, 2 or 4. Okay, and organic compound, be careful with this word. Combustion of organic compound produce carbon, hydrogen, and oxygen. Okay, so that's it. So what you need to do is to read and study more and try to answer exercise on chapter 3.2 notes. Okay, notes chapter 3.2 on page 10 and 11. The answer is already there for you to check, so you can do your own exercise. Good luck.